A square coil of side 10 centimeter consists of 20 turns and carries a current of 12 ampere. A coil is suspended vertically and the normal to the plane of the coil makes an angle 30 degree with the direction of uniform horizontal magnetic field of magnitude 0.80 Tesla. What is the magnitude of torque experienced by the coil? That is given data. So first thing what is given is the side length. I take that L equals, that is given as 10 centimeter. I can write it as 0.1. I take that N is equal to 20 turns. Then the next thing given is carries a current of 12 ampere. So the current given is 12 ampere. So I is equal to 12 ampere. The situation here is the coil is like this. It is suspended vertically and the magnetic field is going like this. The magnetic field is horizontal. So B is 0.8 Tesla. Then what is the magnitude of torque experienced by the coil? So what is the situation here is, if this is my coil, which is a square one, and showing you the side view of that thing, and this coil is at an angle of, so this will be the normal to the coil. This is the plane of the coil. It is slightly like this, and the magnetic field is going in straight lines like this. If you check with this one, and this one, that is the magnetic field, and this normal to the plane makes an angle of 30 degrees. So I can take theta equal to 30 degrees. What we need to calculate is torque, tau. So for torque, the tau equation is NIAP. And that will be followed by, if there is an angle, it will be followed by sine of that angle. Now out of these 5 quantities, N is available with us, I, that is the current, is also available with us, B, the magnetic field is available, and also the theta is available. The missing term here is the area term. So I can directly calculate the area. The shape is given as square, so A will be equal to L square, and there is going to be 0.1 square, because the side length is 10 centimeter. I can write it as 0.1 meter. So area becomes 0.01 meter square. So 0.1 into 0.1 will give me 0.01 meter square. Now directly substituting the values, N is 20 into I is 12 into area, we just now found 0.01 into magnetic field B, that is given as 0.8 into the final thing is sine theta, and sine 30 directly I will substitute as 1 by 2, 0.96 Newton meter. So that is the amount of torque that is going to be experienced by that coil which is suspended in a uniform magnetic field. 2 moving coil meters, actually the word should have been the moving coil galvanometer. 2 moving coil meters M1 and M2 have the following particulars. Then some data is given regarding the details about the 2 meters are given. Resistance R1 is given as 10 ohm, N1, that is the number of turns in the first meter, is given as 30. Area of the coil of that first meter is A1, given as 3.6 into 10 to the power of minus 3 meter square, and the magnetic field inside that meter is given as V1 equals 0.25 Tesla. So then the same details are given for the second meter. R2 equals 14 ohm, N2 equals 42, area 2 is 1.8 into 10 to the power of minus 3, and the magnetic field there is 0.5 Tesla. The spring constants are identical for the 2 meters, so we are using the same spring, or the spring which is made up of same material. We need to determine the ratio of current sensitivity and voltage sensitivity of M2 and M1. So in a way they are asking for the ratio of M2 by M1, and that is in terms of current sensitivity and the voltage sensitivity. So first, obviously, as we always do, we have to write the given data. R1 is given as 10 ohm. Then the next thing is the number of turns. N1 is given as 30. Then the next thing, area A1 is given as 3.6 into 10 to the power of minus 3 meter square. Then the next term here is the magnetic field B1 is given as 0.25 Tesla. Similarly, R2 is given as 14 ohm, N2 is given as 42, and area 2 is given as 1.8 into 10 to the power of minus 3 meter square, and the final thing B2 is given 0.50 Tesla. And one more thing that is indirectly given is the spring constants are identical for the 2 meters. So it will be K1 equals K2 equals, I will just take it as K. Because the spring is made up of same material, the spring constant will remain same. So part A is about current sensitivity. Now the current sensitivity, the equation which I had given day before yesterday was phi divided by I, and this was NVA divided by K. Now this term we can keep it as it is, or because we have to take the ratio in this one, what we can do here is I can take this as IS, that is the current S for sensitivity. So IS is phi divided by I, that is the amount of deflection produced per unit current, and that equation was NVA divided by K. Now in this case, we are going to have two current sensitivities, one is for meter M1 and one is for meter M2. So in that case, what I am going to do here is, I am going to take it as IS1. So this is going to become N1, B1 and A1. We don't need to write that K as K1 because we don't have that separate K1 and separate K2. We just have the K1 and K2 are same. Now this is for IS1. Similarly, I can frame an equation for IS2. That will be again phi divided by I, that is going to be again NBA divided by K. Again in this case I am going to take it as 2, 2 and 2. Now so it will be IS2 divided by IS1. Now if I take the ratio of these two terms, the K is same, so it is going to cancel out, that is known. So in the numerator, what I am going to get here is, it will be N2, B2, A2, because it is IS2 in the numerator. Similarly, there is IS1 in the denominator. I can directly write this as N1, B1, A1. And this can be written as just substituting the values. Now N2 is 42 into B2 is 0.5 into A2. A2 is 1.8 into 10 to the power of minus 3 whole divided by the number of terms in 1 is 30 into the magnetic field is 0.25 into area is 3.6 into 10 to the power of minus 3. Now immediately what we can do here is this 10 to the power of minus 3 cancels out. Then after that, one more thing what we know here is there is a 0.5, 0.25, 0.25 ones up, 0.5 twos up. That is, these two will cancel each other. Similarly, there is a 1.8 and 3.6. It is like table of 18. So it is 18 ones up and that is 18 twos up, 36. So again I have got a 2 in the numerator and 2 in the denominator. I can cancel that 2 as well. So what I am left with here is only 42 by 30, and we come across that 42 by 30 in the table of 6. So I can write here is IS2 divided by IS1 equals 6 7s are 42, 6 5s are 30. So it is going to be 7 by 5, or it can be written in terms of decimal as 1.4.